All right, we are live. I hope people can hear us.
Yep.
Can they see us? Those poor things. Comments, there we are. I'm joined by the legendary, my friend, Billy Korando. How you doing, my friend?
Good. How are you doing, man?
You know, we've known each other for a very...
Actually, it has been
very long time.
a very long. the way you say that, though, it doesn't seem like a good thing, though.
I'm so excited to be here. No, actually, no. I'm you know that meme? What's that meme? This one. I don't know.
Yes, I know that one meme.
The one
yes,
meme.
The one meme.
The meme of I used it today, right? Like this one. I like seeing you, but it's really annoying because this one, right? This one.
Congrats, happy for you. No.
Right. Like every time I see you, I'm like, oh, he has access to burn ends and I do not. So I'm happy for you. Congrats. Nice.
Yes, very upset though.
Yeah, I really am. It's frustrating. Like you remind me of things I don't have. You live in
this small town called Kansas City,
which is one of those few cities that straddles two states.
Yep. I frequently hear it's like, oh, what's it like in Kansas? And being on the Missouri side, I'm like, and I get it. No one really cares why. And also you hear Kansas City, it's natural to assume Kansas.
Yeah, it's in there. It's in the name.
No.
And also it does exist in Kansas.
It also does, yes.
Yeah, so
and they're drifting on our name. So Kansas City, Missouri is before Kansas City, Kansas.
Really?
Yes.
How come I didn't? Wait, why would they have okay, now I have questions.
Because the territory of Kansas came after the Kansas City. So like I think the city got founded, but then it got split to where it ended up in Missouri instead of Kansas. So like originally it was founded, I believe it was in the territory of Kansas. But
why didn't they just carve the state line so that it was just like
we're like on the it's on the Missouri River that like bisects it.
Oh, that's so fun.
Yeah. Oh, really interesting history. I'm sure everyone, like especially people outside your country or outside the United States, like, wow, it's really interesting to hear about.
It is actually interesting to hear about this kind of stuff. It's good to see you, even though you didn't bring me. You know, our friend Nicola Frankel.
Yeah,
every time I see him, he lives on the border between France and Switzerland.
He's like completely surrounded by France. He's like in that little.
Right. But every time I see him, he brings me Swiss chocolates.
Oh.
And I just keep expecting you to pop up with a box of like
some
meat for you.
Meat, yeah. Here's some meat for you.
Never happened.
Didn't refrigerate it.
Still fresh. You mean 2 days old? Yeah.
Yeah.
Well, anyway, I'm really happy to see you. Can you tell me in like 5,000 words or less what you do?
So I not too different from you. We're not too different, you and I. You work as a developer advocate for the Spring thing. I work as a developer advocate for Java, the Oracle Java developer team. So,
big fan.
Yes.
And we are today at UberConf. We're actually in the hotel room that I have.
Yes.
For this conference that we're both at.
Yeah.
Called UberConf.
Yes.
Yeah. Good show.
It is a good show. Yeah.
Have you been here before?
It's really, yes. Yeah. I've done, this is my third or fourth UberConf now. So no, it's always great. And one of the nice things about UberConf is they do 90-minute sessions. So you can get a little bit more of a deep dive into the topic. So that's always great. And actually just got done with a workshop that you and James Ward did.
Yeah, that was fun.
Agentic development. That was very interesting.
Spring AI.
Yeah, Java. Spring AI. Yeah.
We have and thanks by the way for all of your contributions.
Yeah.
It was nice of you to find so many bugs.
That's just what I do. I love to find bugs and point out flaws in other people.
Who asked you, Billy?
Exactly.
No, it's good. So happy. Thanks.
Yeah.
So nice.
Thank you.
Nice.
Thank you.
Congrats.
The insistence on the thank you is this real.
Well, I was really glad to have you.
Yes.
obviously.
Josh is texting people.
Who's the next podcast guest. Not that I'm thinking about a world after you.
What there's after me, there's actually a world outside of
there's
me.
There's the deluge. I'm really happy. Got to do that workshop. That was fun.
Yep.
I truly believe that we in the Java community have this like unparalleled opportunity, you know?
Yes.
And when I say Java, I mean the JVM community writ large, you know, to seize this moment in generative AI, you know?
Yeah.
Obviously, that there's two components to that. The framework story, the tools, you know, how do you build these things? What are the Lego bricks upon which to build? And then the language and runtime story.
Yeah.
And I know the tools side, you know, and Spring AI included, have been, full on sprint.
Yeah.
You know, racing we're racing to lead. You know, like I believe that it's not just a better time to be a JVM developer for AI. It's the best time. There's no better way to do generative AI programming today than on the JVM. Absolutely. And thank you. And then the counterpoint to that, of course, is the runtime. And there, I've been very impressed. I mean, my goodness, it feels like if I close my eyes, there's a new feature.
Yeah.
That makes it just a better choice, you know, all the time. And we're now 2 months, 1 month and like minus one, 2 months and minus 1 day.
Yeah.
Right. Just 1 day less than 2 months. Yesterday, the 14th of July, was 2 months out from Java 27.
Yep.
Which comes every 6 months.
Yep.
It's like clockwork, you know. Big release.
Death, taxes, and the 6-month release cadence.
Oh, I love it. That's only one good thing there.
Yeah.
Hey, George. Hi.
Hey. Oh no, George.
So good. I'm a big fan.
Yes.
So this Java 27 release, I've been waiting. I saw you yesterday. I'm like, oh my god, 2 months, right? I'm so excited. One of the things that we've been talking about internally is just like, okay, the compact object headers thing.
Yes.
So good. Can you tell us tell me stories about my favorite features, and tell me about the toys I'm going to get in Christmas and what are they like? I want to imagine playing with them, you know?
Yeah, absolutely. So on the topic of Java 27 and the runtime, that is kind of one of the big things that's coming in Java 27 is some updates to the runtime. So one of the things that you're talking about is the compact object headers. So kind of through the analysis that our JDK team does is that they found that on the heap, so of course all reference types in Java, which of course almost everything's a reference types outside of the primitives.
Yeah.
They were finding that generally speaking, the actual what was contained within the reference type, the actual data, that the business meaningful data or application meaningful data in there was usually pretty small. I think it was maybe a couple of kilobytes, or maybe not even that, but a very small size. And then the analysis also then is that when we say reference type, it's because it's being referenced in memory. And so you would have metadata information about okay, yep, this is where this reference type is located on memory, and then this is where it's also being referenced by other objects. All this metadata information for tracking. And often it was a case is that more information on the heap was being taken up by just the header information than about the actual business meaningful information. And then through further analysis by all the brilliant JDK engineers is that that wasn't necessarily all needed, that it was excessive, and that could actually be compressed down. And this has happened a couple of other times. There's been compressed object headers that was added some releases ago that kind of reduced the header size. But then I believe he was with Amazon Roman. I can't remember his last name, but he's the one that kind of headed up this project through Project Lilliput, where we could see about farther reducing the size of object headers. Lilliput, yeah.
The giant, what's that?
Yeah, I can't remember. I know it's a familiar word, but I can't remember where it comes from.
Yeah.
But yeah, we do various projects, and we can get to that in a minute.
Yep.
for various things that we're working on. But anyways, to do that, we added this feature to further reduce the size of the headers for objects on a heap by about half. At one point, you could have told you exactly how many bytes it's taking up now, but it's reduced. And of course, the net of that is
Gulliver's Travels. That's what it was. Gulliver's Travels.
That's perfect. Thank you, George.
Thanks, George.
By reducing that, the net of that is you get greater data density, and then you also reduce, by using less memory, you also reduce the pressure on the garbage collector, which means less garbage collection cycles are happening and all that. So so that it's to reduce your memory utilization, which will reduce your latency, and overall result in better performance. So the change is that this was introduced in JDK 25 as it was just available, and you would have to manually turn it on. And now with JDK 27, it is a default feature.
Also, it was a GA feature in 25, but not you have to opt in.
Yeah, opt in, exactly. It was experimental even before then. So I think it was experimental definitely in 24, maybe 21 or 22 was added as an experimental feature.
This is so good. This is the kind of stuff where it's like, this is why you use a runtime that you can just migrate towards. You can take that same program, just do the thing, update every 6 months, get better everything, things get better all around,
Yeah, no, that's really one of the biggest benefits to keeping on the 6-month release cycle is that there's not necessarily always going to be a major new language feature or API feature, but you will always be getting those benefits of improved performance with every release. It's just a few, every single one, but they build up over time.
Oh yeah, I mean, I did an accidentally 9.5 hour long workshop yesterday. I did a whole thing in this
That's
workshop.
It, just 9.5 hours.
Yeah, well, it was because I had a lot of time. I was able to do like a whole thing about Java for the uninitiated, right? And it wasn't like I wasn't preaching to a choir of people who had never done Java, although it turned out there were some of those. It was more about this is not your grandma's Java. You know what I'm saying? Like this Java is totally different today. The language, the syntax, the capabilities, and it was just I didn't expect it to take 45 minutes, but it was a 45-minute section of this 9.5 hour thing, really quite impressive syntax. So there's no shortage of that, is all I'm trying to say. But the runtime stuff is, oh my goodness, not related, but also in the same vein. In 9 months, which is 8 months, I guess if the math is right, we're gonna have a preview of Valhalla. Last I heard, maybe.
Yeah. The goal, the plan right now is still JDK 28. Is that okay for me to say, George? I think we publicly announced that. I think the public PRs are on there. So yeah, that's the goal. We're all very excited. I mean, the amount of work involved in that. So
I've been watching the PRs
the PRs, and like some of them are like it's like 1,600 files being changed. I mean, and it's not in that probably doesn't even fully cover it as well. I mean, obviously there's a lot of files to be changing, but just it is such a substantial change to the JDK because now we're allowing to potentially have things that used to be reference types to potentially no longer be reference types. And so that is going to be massive.
Yeah, I mean, I can't wait. We'll definitely talk about that as we get closer to that preview and every 6 months after that, of course, because that to me is like, oh, I cannot wait. I cannot wait. I'm so excited. That one in virtual threads, two of the biggest features in my small little brain.
Yes,
two of the biggest features ever to be added to the JVM, and it's already one of the most performant. I harp on that. You saw I did. Yeah, we did an AI talk. Yes, James and I did an AI talk, and I still spent my usual 10-15 minutes just driving home the point that the JVM is top shelf performance. Okay, so anyway, very excited, and I love this compact object headers. I'm looking at a Google AI overview, so correct me if I'm wrong. It's just I don't know where it's sourcing it from. Who knows if it's correct? It's saying, hey, compresses object headers to 64 bits. Thank you. Applications with many small objects can save up to 20% on heap usage and boost throughput by up to 10%. Your mileage might vary. Why MMMV? But if it's it's free. What do you got to lose?
Exactly.
By the way, you should be upgrading anyway.
Always.
Even if there is no compact object headers, upgrade, because there's other things that are really nice. And one of the things that there's two, I think of this as like 3 vectors of motivation, right? 3 dimensions for that motivate my upgrades. One, as a developer, like shiny toys, I like new syntax. It's nice. I'm not gonna lie, that's the sweetest part of the upgrade for me. But there are other toys in the bag. The other one is, of course, performance and runtime improvements. Make it more stable, more scalable, whatever. And then the third one, and increasingly important today in the world of AI, security.
Yes.
Right. Yep. And so, next up on this list, I see a very, very interesting JEP. And is this the current name? I don't know. JEP 527 post quantum hybrid key exchange.
Yeah.
I don't know. I can read the description here. Harvest. It protects against harvest now, decrypt later attacks by automatically combining standard algorithms with quantum resistant encryption for TLS 1.3 connections. I think most people will just not notice this, which is the point, right?
I believe so.
It's most of automatic.
This, it should be mostly automatic. I think a lot of this would actually be our mutual friend Rob Lynch, who's the head of Spring Security. It'd be about like a lot of, I think, library developers, and actually this would probably even be below what Rob does. But adopting this, it's definitely outside generally of my expertise.
Sure.
But like one of the big issues right now is like our general issues of security, and as it's kind of in that summary is like the harvest now, decrypt later, where you compromise a network. You can't necessarily decrypt it, but you can harvest this information, and eventually maybe when you have access to some sort of quantum computing that can then easily break the algorithms for encryption, then you can all this stored information, you can then decrypt it and break it. It's actually funny. So I had a realization recently that like I have not been reading nearly enough. And so one of the things I actually have been doing over this spring and summer is actually reading the Expanse books. So The Expanse, of course, it's all books. And
have you watched the show?
Yes. Oh yeah. So I watched the show. Now I'm reading the books.
Here's my problem.
Yeah.
I've successfully finished the first season.
It
was good.
Yeah.
I'm told the rest are better. Is that true?
Yeah. Yeah. All the other seasons are really great. The last season, like it's probably the weakest of them, but by then you're also still very invested into the story. So it's great to follow. The books are excellent. It's actually, I feel like the first book, in my opinion, was the weakest of them. But otherwise, all the books are really great. But at least where I was getting with that is in one of the books, actually the Harvest Now, Decrypt Later is actually a plot line.
Oh my God. I didn't really. Oh, spoiler alert.
Yeah.
So I've been playing this game of cat and mouse with the Expanse. Did you watch the show The Wire?
Yeah.
Okay. Took me 20 years
to watch it. 20.
I knew it was good. Everybody told me it was good. Yeah. I know it's good. And then it was like 2004, 2003, whatever on HBO, I think. I don't know. Forgive me if I'm wrong. The producers of The Wire. But I knew it was good. Everybody kept on telling me it was good. But that first season was such a slow burn, and so I kept on drifting away. Like I just can't. Who's got time for this? During the pandemic, imagine I had some downtime. So I watched it. I just said, I'm not getting up. I'm going to turn off my phone, turn off the iPad, turn off, everything. I'm just going to sit here until I'm done. And it paid dividends. It was an amazing show. It sat with me. It still sits with me. It's one of my top 5 best shows I ever watched.
No, it's excellent. It is a very good show.
And everybody keeps talking to me about The Wire. And I tried with that first season, and I just
The Expanse, but
The Expanse, and I don't want to wait 20 more years. I just don't have it in me, but I might.
Yeah, so, I don't. It for me, I think it's one of my favorite sci-fi series.
Really? Okay.
Yeah. So
and you're pretty smart. So if you say it's good, I'll try again. I'm sorry. Okay. Anyway, Harvest and Decrypt. That's interesting.
But yeah. Anyways, so yeah, that's it. Anyways, that ends up being Harvest and Decrypting Later ends up being a plot line from one of the books. I won't say what's to limit the spoilers and all of it though, and it's not like too spoilerly. But anyways, I just thought that was relevant.
That's cool.
But yeah, so another of the JEPs coming is G1 default in all environments. So the G1 garbage collector, generally speaking, if you just do, Java and whatever, but don't specify a garbage collector, it should be G1.
Yeah.
But what we were finding is how a lot of people were kind of by default configuring their containers within usually a Kubernetes environment or whatever, is like their memory or their CPU grouping would be so low that it would maybe only show like one CPU core, or I can't remember, it's like sub 2 gigabytes or sub 1 gigabyte of heap space.
Right.
I mean, it may be actually be set high, but the C groupings, whatever, to where it would sometimes default to using the serial garbage collector. And that would have sometimes some performance issues just because the serial garbage collector, as its name suggests, is kind of based around a very limited CPU architecture with only a single core. Yeah. So that means that every time there's a garbage collection, it would stop everything and slow. And so anyways, now it should always be the G1 garbage collector unless you select one of the other ones.
But what happens in the case of those small single core environments, though?
So for those other environments, I think some of that is also a case of some other changes about better detecting underlying hardware. Because again, I think some of it is C groups where it would sometimes in some hardware architectures, it would only find a single CPU thread where there was actually more, or CPU core when there's actually more available. So I think a lot of that other detection is also helping. And of course, obviously, if you're finding in your environment that G1 is too heavyweight, then you can of course always default to using the other ones like serial, parallel, or ZDC.
Or just upgrade your environment.
Yes, that too.
Yeah. Single core is a weird thing to say in a server production environment.
Yeah.
Okay, I'm a fan. This is cool.
Yeah.
I don't feel like I'm running. Here's the problem. I write my code on this really beefy laptop.
Exactly.
I can run Slack.
Yeah. Yeah, I know. That's impressive. I mean, if you can get to Slack levels, I mean, you have all the resources in the world.
Yeah. Really, really powerful device. Yeah. So I don't feel like I'm being particularly inhibited by my Java. But then to find out that you get to production and it goes slower, that's everything goes slower compared to my Mac. You know what I'm saying? But yeah, I also don't run on single core, so it's not that much slower. It's it's still fine in my production environments. But yeah, single core would be.
Yeah.
Okay. JFR data reflect. What the hey?
So basically, this is about making sure within your JFR recordings that you're not unintentionally leaking sensitive data. So for example, if you're passing in some tokens or a database password and stuff like that as your environment variables, which would generally be the case, there was a possibility before that could be unintentionally leaked within a JFR dump file.
Data redaction. That's what the feature is. JFR data redaction.
Yeah. So by
536.
By default now with that one, it will automatically detect those common use cases. But of course, if there are other potential use cases where you would want to redact information, then you can also configure it as well to make sure that will redact that potentially sensitive information.
That is interesting.
Yeah.
I'm kind of curious about how it knows which environment variables or whatever to
I think it'll be looking for things like password or token or API key and stuff like that.
You can actually specify.
But yeah, you can further specify it as well.
Oh, okay, interesting. By default, the flight recorder redacts all environment variables or system properties with a key that matches one of the following patterns. When they say key, they mean property file key and value. So API asterisk key. So asterisk API asterisk key. Asterisk auth asterisk client asterisk secret. So one word.
Yeah.
Asterisk. Actually, let me just try it this way. Every one of the following words is a wildcard in the beginning and the end. Okay. Yeah. So credential, JAS asterisk config, JWT passphrase, passwd, password, private asterisk key, PWD, which is they got that up there. Yeah. Secret and token. That's interesting.
Yep. So yeah, and like I said, you can further configure that as well if there is maybe other things that you might be passing in that you want to be redacted. Yeah.
We have the same thing in Spring Boot. When we did Spring Boot 1.0 back in 2014, we had the actuator. I know. And Java and Spring Boot go in the distance. I love it. Spring Boot 1.0, we came out with the actuator. Actuator, for the audience, if you don't know it, it has endpoints that surface information about the application so that you can ascertain its health and its state, right? So things like the health indicators and metrics and all that. We also have an env endpoint, and the env endpoint gives you your environment. And at first, I think that was wide open.
Then it's like, ooh.
And it also gave you, maybe it wasn't wide open, but it was like, if you enabled it, the passwords were shown, right? And then it's like, oh, hey, we should actually have a mechanism to filter that. And so we did the same thing. Now I think everything is masked by default, right? Every environment variable is shown, but the password, the value itself is masked. And you can now opt out of the masking as opposed to opting in. But it was a process. It took us years to like land somewhere there, and same thing.
It's always the things like how, to what extent do you want to be cautious versus so
this makes sense. I can feel
you can feel the learned experience you guys went through with that as well.
It's a common thing because it's a really useful. You want observability, but also
there could be issues with that potentially.
This is, by the way, the privacy. That thing is one of the reasons why I haven't really been able to get 100% behind Project Crack, right? Because it's capturing a photo of your entire processes, working memory. It's like, I can use Leiden for that.
One thing I do want to kind of pause briefly on JFR a little bit before this. We were talking about this thing called AI. I don't know if you heard AI. So one of the things we are finding is like, it's still a bit hit on or miss when you go into your preferred AI development tool and you say like, hey, let's build this feature. If it's a large enough feature, AI can still kind of struggle with accurately putting that together to where it works as expected. But what we're finding is, and also this is a particular advantage because of Java, because actually Java is extremely well documented. We were briefly talking about Kubernetes as well, and remember being very frustrated at times with Kubernetes documentation, but Java's documentation is really good. To where we're finding that when combining it with something like JFR, it can actually work really well as an ops engineer. So it can use like the tooling, the various things within JFR to like periodically pull application in production, using the various tools within JFR to do analysis on a JFR recording to see like, hey, okay, what's our memory utilization, what's the CPU usage, all these different things. And it's like, again, and then kind of based upon heuristics that you can put into it, saying like, hey, if it's, getting above this level consistently, that might be an issue. And then from there, it could potentially try then to track down maybe where the problem sites that could be coming from, and then try to offer fixes. And so one of my colleagues, one of our JDK engineers, Yagmer, if you look on the Java YouTube channel, she has a really great presentation on kind of doing exactly that.
So cool.
But yeah, no, that's a very interesting thing. And of course, obviously, a AI agent never really gets tired. So it could be at 2 a.m., 3 a.m., or middle of the day, whenever. You can always be consistently checking to see whenever performance issues might come up, and then offer a fix.
That is amazing. The JFR stuff, we shipped new support for it in Spring Batch, the new version of Spring Batch.
Fantastic, yeah.
Has JFR like integration out of the box, right?
Fantastic,
Because if you're running a batch process, you want to be able to see what's happening. It's a long running thing, and having the ability to now, I hadn't never even thought about that. Having the ability to say, "Hey AI, I've got the best tools in the world to understand what's going on. I've got this amazing runtime that will spill all of its secret if you ask it nicely. Go do the thing." Like, oh, that's actually really cool. I never even thought about that. I love Java. So good. So good. Lazy constants. This is all about this. They should just call it the Josh constant.
The Josh constant.
Yeah, that's me. Okay. Adds the set of lazy factory method, completing the lazy variants for all 3 basic collections. What is?
So what this is basically it's offering you the ability to have. So with final, you know, when we need to clarify a variable, you need to set it at that time to whatever its value is going to be. Sometimes it can be a bit restrictive. The somewhat canonical example that's often used is like a logger that you don't necessarily want to set that value either at the initialization of the class or an instance of it, but maybe at some point just a bit later you want to set it, but once it's set, it's not going to change. And so the JVM, you know, our favorite thing, you know, it can be very smart to say like, hold up, this value, it's never going to change again for, you know, for the lifetime of the either this object or the JVM. And from there, it can do some optimizations around that using the JIT, the just-in-time compiler, to improve the memory utilization or the throughput of the application. So basically what it's saying is just like, hey, you get only one chance to set this. It doesn't have to be at class or instance initialization. But then once it's set, it's not going to change.
That's so cool.
Yeah.
That is so, and it's so much more natural than like at startup time figuring out this value. Sometimes there's a context they need later in the program. Yeah.
Exactly. So that's exactly what it is that, yeah, if you just need something just a little bit later, then what final allows for, this allows for that.
I'm a big fan.
Yep.
That's a GA in the release feature.
Is it GA? I thought that was still preview for this one.
Oh.
I double check.
Third
yeah,
preview.
Okay, I was like, wait a second, I didn't think that was.
Oh no, it says completed 27.
Well, that it's completed as in it's integrated, but it's third preview for this. So, see, that's why you shouldn't trust AI summaries. It was saying that this was going to be a final feature, and it's not quite there yet.
Well, that's a bummer. When does it go real then? This is a preview API. You're right.
I'm not sure. Hopefully, it could be 28.
I'm so sad.
So some of that will come down to how much changes are happening between the releases. But you know what? Better to wait and get it right than rush it out and get it wrong.
Very true. Very true. Speaking of other previews, 2 things I've been waiting for: structured concurrency.
Yep.
And primitive type patterns. I talked about primitive type patterns yesterday in the workshop. I mean, just like that's one of those things where it's like a small step towards Valhalla. You know, that unification of these primitives versus object references. That's really cool. And that's the primitive type patterns is like you can do instance of on a. You can see if a narrowing cast would work. Yeah. Right. Is that the idea? Yeah. So if I have a.
Yeah, it's about, or I guess kind of to you, just having better unifying between reference types and primitive types.
So good. Yeah. And it's clear there's care. It's like all these little places. There's these nooks and crannies where we've, you know, like if you want really fast code, there's no better way to do it than primitives. So it's not. I don't begrudge anybody that disjointed sort of hierarchy that we have, but. Oh, I can't wait for them to find a way to make these things coexist even more nicely. You know?
But structured concurrency that's like one of my features that I'm most looking forward to, and that kind of gets back to what we were talking about earlier with virtual threads. So virtual threads were added back in JDK 21, and of course, just to briefly go through it, virtual threads are about improving the horizontal scalability of Java by creating a lightweight thread model, and so then structured concurrency, like, it's going to go so together so well with virtual threads, because like one of the difficulties right now, I mean, it's of course perfectly possible to write concurrent code in Java, but when you have like a parent task and then it's being split off into a bunch of subtasks, the ability to reason about all those subtasks, it's somewhat limited. Like, you know, what happens if one of the tasks fails? What happens if one of them is long running? What happens if you have like 10 concurrent tasks and 2 fail? Like, is that different from just 1 failure? So, you know, all these things are possible to, and then of course the final one is also debugging. You know, if like you have a parent task, it spawns off a bunch of subtasks, and one of those tasks fails because maybe some null value is passed from the parent task to that subtask shouldn't have happened. it can be difficult to track that back.
Yeah.
So structured concurrency, the structuring is that there is a relationship now between the parent thread and then all the subthreads it spawns off.
Right.
And then it allows you to reason about those subtasks all together of like, okay, if one fails, then, cancel the rest. If one succeeds, maybe cancel the rest, or if they all succeed and all that stuff. So it's going to be very nice. It's like I said, like concurrent code has always been very difficult just because there's a lot of complexity there, and it greatly simplifies that complexity. So I'm really looking forward to when that's added as a final feature.
Yes, me too. I'm looking forward to that. Every one of my demos includes a discussion around virtual threads.
Yeah. Everyone.
It's free. It's free scale.
It's
There's
free. Yep.
never ever a reason not to use it. And if you're nope, don't. I know you're gonna say JNI references will give you.
Or,
doing JNI.
I mean, if you're CPU bound on what you're doing, then virtual threads isn't.
Ignore him.
Ignore.
Just use virtual threads. It's so good. It's almost never going to be an issue to do that.
Yep.
And so I talk about it all the time. Love virtual threads.
Yeah.
It's free scale, and it's one of the. It's one of the reasons why. There's so many reasons to upgrade, but if you have to pick one, just do that. Go to your management and say, "Hey, look at these numbers."
Yeah.
Just benchmark your service. I guarantee you'll enjoy the results. Right? In the demos I do, I use a pretty trivial example where I'm calling a remote service and spending 5 seconds waiting for the thing.
Yeah.
That doubles.
Yeah.
And I force my web server to 10 threads. Right? It doubles. I get 200% more scale. It's an amazing result. So just use virtual threads. I talk about that all the time. And then I also prefer when I want the impossible things to be possible, and then I want the hard things to be easy. But I want the impossible things to be possible. I don't want to, like the GIL in Python is, they just don't have. There's certain things you just cannot do because of the fundamental design. Whereas Java can do everything, right? And some things can be made easier, but you can do it. It's already possible. It's just not as easy as it could be, perhaps. So I very much appreciate the trade-offs. The choice to go and do the right thing and support everything.
Yeah. No, and at least a little bit also to kind of, again, how virtual threads in a lot of use cases improves the horizontal scalability is that for particularly when you're writing web applications, which a lot of Spring developers are doing. Imagine. Is that when you get a request in, those requests are then mapped to a thread. And so before virtual threads, it was been mapped to your a thread, which is then mapped, pretty much one-to-one with the underlying operating system thread. And so, those can get used up pretty quickly. And so then when that happens, that means that the next request that comes in has to wait until a thread's available. Now, and again, as simple as just an application property, use virtual threads. Now, when a request comes in, that's mapped to a virtual thread, and a virtual thread is very easy when it runs into like some sort of database call, web service call, where it's just going to sit there and sleep until it gets a response back and just be put into a queue, and then you can get something else to get working. So it's just free scale.
Free scale. It's
free scale.
Real dollars and cents. If you can. People are spinning up new instances to handle extra capacity. You could spin down, and by the way, I don't know if you've noticed, RAM's not cheap right now. So the fewer instances you can run, it's real money. Spring.threads.virtual.enabled in a Spring Boot, make that true. And run in the Spring Boot application. That's real performance. I huge fan.
Is that a default feature now?
No, because for reasons I will never understand, we still support in Spring Boot 4, technically Java 17.
But I wouldn't.
Ancient, creakingly old, long since irrelevant software. I would never use in production, except to. I would never use it at all, except to show people, ironically, what you should never do. Right. But Java 25 and Java 24 fixed the last remaining gate. For Java virtual threads, and I've been using it since 21. My favorite feature, and then Valhalla, of course, will be my next big favorite feature.
That's the big one.
The service orchestration use case of that's what structured concurrency seems like it's going to be perfect for. Is I have to do multiple things in concurrence. And, there's another thing, because of virtual threads. This is another wonderful thing. It's a great problem to have, because virtual threads makes it so much easier to do so much more with the same code and the same computer and the same CPU set. Because virtual threads unlocks all that scale. we on the Spring team have recently in Spring Boot 4.1 enabled something that was possible, but it wasn't the default for decades. We had this thing in Spring called the lazy data source connection proxy or something like that.
Yeah.
And all that does.
Bad memories.
Bad memories? How dare you?
Well, I don't know. Maybe it was my side. Just where.
What happened?
Oh, I don't know. I'm pretty sure at some point I had some sort of error that involved lazy, and it probably was more an error on my side. But
I need to know. Well, okay. Yeah. When it works, what it's supposed to do is it's a proxy. It wraps around your connection, your data source. And so, speaking in the example you just mentioned, you've got a thread that hits the servlet API usually. Usually it's synchronous. The servlet and then invokes Spring's dispatcher servlet. Servlet container invokes Spring's dispatcher servlet. Then in that, you get your controller handler method invoked. And then in there, probably, it's a controller, so it's going to adapt the network request to some backend business logic. And in there, you're probably going to talk to a database, right? And in that work, you probably have transactions going. Right. And so when you invoke a service, when you have an @service class, and then you put @transaction on that ends up starting a transaction as soon as the method is invoked, and committing the transaction as soon as the method is finished. Assuming there's no exceptions, in which case it'll roll back. The problem comes if you dilly-dally at all in that method. If you're sitting there like making network requests or whatever, things are going across the wire, but you're not writing anything to the database. Right. And so during that time, you're waiting for two things. First of all, there's two things that are waiting for you. Without virtual threads, the thread is waiting for you. As you make that network request.
And the database connection.
And the database connection is open. You've got one of the finite limited set of connections open, and you're not doing anything with it yet. You haven't issued SQL. You haven't written something to the database. And so that's a scalability bottleneck. So the first problem we can fix with virtual threads, enable that, and now that network request won't bottleneck a single thread. And then with this new Spring Boot feature, lazy connection equals fetch. No, is lazy. Lazy connection fetch equals data source connection fetch equals lazy. I think something like that.
Okay.
It'll wrap your data source with this proxy, and now when you get a connection from the connection pool, it won't actually obtain a real one from the underlying actual network data source until the very last second when you actually do something that requires SQL.
Oh, fantastic! That's
awesome. So now you can we don't want to encourage the bad code, but at least that bad code won't be so expensive. So then again, it's one of those things where it's compounded. Virtual threads meant I could actually handle more requests to my controller handler method in the first place. And now we're like seeing the database downstream starve, because there's too much traffic, So this is it's a wonderful problem. I love virtual threads. Okay. Anything else? There's a bunch of there's a bunch of extra features in this blog that we're looking at here. That look interesting.
I think it's just covering all the JEPs. I haven't gone through it yet. So as we get closer to release, always one thing I like to do is I put together a video covering the release and maybe a few blog articles where I go through like every single feature or virtually every single feature within it. I guess it does cover a few more things.
Huge.
But like most of the times, the important things are following the JEPs, the JDK enhancement proposals. Those are the major changes, but there would be also a few other changes within every release of, smaller updates, or in some cases, sometimes a bit more significant updates as well. So kind of like last one, JDK 26, like there was like another fix to pinning issues with virtual threads that was just, fixed for free.
Just love that.
So,
Such a great release. I can't wait. I can't wait for Java 27. In 2 months minus 1 day, it's coming out. I cannot. The 14th of September. Right. Not the 15th. Usually it's the 15th. I feel like.
It's usually a Tuesday, so it's usually been like the second Tuesday, or I guess that would be the third Tuesday. Some people, it's always been Tuesday since we've gone to the 6-month release cadence.
Okay. Well, I can't wait.
Tuesday or Thursday, something like that. Something like that. Yeah.
It's gonna be great.
Yeah.
Just thank you for coming on and
absolutely. Thanks for having me. Yeah.
I'm not mad that you didn't bring burn ends, but at least you brought Java.
You keep bringing it up. I think you're a bit
I'm a little
upset. A little mad. Well, you can get some when you're in a KCDC in September. So.
Can't wait. Dancing in September.
Yes.
I got burn-ins. Exactly.
Heck yeah, man.
Thank you, my friend.
Absolutely.
Thanks,
you.
everybody, for hanging out.
Thank you. Yep. See you, everyone.
Bye.
Bye.